everybody. Um, I hope that you guys are all doing okay. And I'm sorry about being out so many days. We got to keep going with what we have. So here we go. Notes for 4-4. You have three sides of one triangle. So here's your one triangle. If those three sides are congruent to three sides of another triangle, then the triangles are congruent. So for this postulate, we are going to be calling it side, side, side. And for the three-column page, because that's what you're getting into now, you're going to use this SSS. It's totally fine. You don't have to write the side, side, side. Congruent. And just write SSS. So what this means is if these two sides are equal, AB, and then you get these two sides, which is the two marks, and then you get this side, which is the three marks. How do we use this? So let's talk about this, all right? This is when you want to pull out your colored pens, pencils. It is really important, and it makes it a lot easier if you do that. All right. So the first things first, we're going to mark all of that so that we're ready for to prove this. I'm going to go back really quick. I'm so sorry. This right here. Wait a second, guys. Got that. So this right here is going to be your end statement. What I mean by that is when you're looking at this right here, when you're looking at proving this, this is going to be your end result. Okay, your end result. So what all of this actually will into one. So first things first, we're going to work on your givens. So your givens are going to be in two lines. You don't always have to do it in two. You can do it in one, but I want you to start looking at it as only different. So the first one is TV is 7 is 7 is okay, so you mark that. And TV and AB. That's your given. The next one. 7 is T. This is another 7 AB. And that's also given. Okay. So this one is going for that one is the blue marks, and this one is with the red marks. Alright, so we have those okay. Do you have anything else for givens? Is there anything left here? No, it's only the two statements there. So this is where you get your plus points. Now, I know we haven't talked about this in a while, but we need to let's go back. Let's on this page here. Your best points. So the first one, okay, is going to be this one is your definition vocabulary. Remember that? The second one is going to be reflexive properties. And then the to do with you're still going to be right? So really, really important. Those are going to be your best friends. We're probably going to add to them, but for right now, those are going to be your best friends. Let's go back. So if we're looking at this picture of this parallelogram, do you see two triangles that share? So this triangle right here and this triangle right here, do you see how they share something? Triangle over here and that triangle. Do you see that they share common side, which is right there? Do you see how they share that side? So same thing, exact same thing. Okay, so this little side, this little side, and this little side. So, in the way we actually mark university is between S like that. This is interesting. Okay, so we have all the triangles proven because we have three sides of one triangle is congruent to three sides of another triangle. Therefore, we can state number 4, so I guess there's not going to be a number 5 here. Triangle QUB is congruent to triangle ABU, and the reason? Side, side, side. Okay? Let you guys head over and we'll come back to it. Okay, so take a look at it. Let's go to this page. All right, so we have this triangle. You see what this triangle is set it up against each other. Make congruent using my iPad for the first time in my All right, so let's look at our given. So for the first one, okay, then we have okay. What is all this? Kind of weird. I don't know why this color's still there. Okay. Okay. You guys know me, I'm too much of a perfectionist not to like fix that. Okay, I feel better. Moving on. These one by one do the reason. So let's look at the first one. AC is congruent to AB. Okay. Is this guy right there and that guy right there are congruent? Is there something else? Is it anything? Is it no? Is it that? Okay, so I get it. The next one, okay, we're right. B is the midpoint of BC. All right, I had to fix it. Sorry. Midpoint of BC. We're gonna write given for that guy. Now, that statement is stopping point, end point, like dead end, that's what I'm trying to say. Is that a dead end statement, or does that give us another statement? So let me make this very clear. This statement, number one, right here, okay? This statement, number one, right here, is a dead end statement. That stops, there's no ifs, ands, or buts about it. This one, the second statement, is not a dead end. Actually, something else. So we have to figure out what that something else is. Well, right, the midpoint, that's a vocab word. So if B right here is the midpoint of BC or AC, doesn't matter, or CB, that means that these two segments right there are equal. Okay, let's write that. CB is congruent to CB. What's the reasoning? You just got a vocab word. If that vocab word is used in state in line 2, and it's giving you line 3, then you've got definition of midpoint. Okay? Great. So I've got on statement 1, right here, we've got a side equal to a side. Statement 3, another side equals side. Statement 4 could be another best friend, which is going to be AB is congruent to AC, and the reason is reflexive property. Alright, so alright, we've got a side, a side, a side. Can we do this statement right here now? Sure can. Triangle ABC is congruent to triangle ADB. The reason? Side, side, side. So you take a look at that. Watch over there, and when you're ready, go to the next problem. Okay, so for this one, we need to figure out if the two triangles are congruent. We're trying to figure out if this triangle over here is going to be congruent to this triangle over there. How you do that is by doing this equation, right? And you need to do it for each one. You can't just do it for one. You have to do it for all. So, if you noticed, I only set up the first triangle. Now give me a second. All right, you can see that I've made the other ones possible for you to do. So if we were to do this, I'll do the first one and then you guys are on your own. So this would be the square root. We're looking at this one right here and that one right there. So it would be x2 would be 0 minus minus 5 squared. You can see I'm putting in whatever you like. Plus 3 minus 5 squared. I will shrink this once I get everything together here. That's going to equal, this is going to be right here, this right here is going to be 5 squared, plus this right here is going to be negative 2 squared. There we go. And the square root of 25 plus 4 equal to the square root of 29. Let me clean it up. So if you were to go through all of it, then you could prove that one triangle is congruent to the other. The sides have to be the same. So like A, B, and D, E would have to both be the square root of 29. Okay, so for the next one, side, side, now we're going to learn about side angle side. Nothing different. Okay. Angle has to be in between two sides. So you have to make sure that you have two sides good. So we've got this one right here, and that one right there, this one right, right? And then we have this one over here, and that one. And those two being congruent helps you see where you angle needs to be congruent. Kind of a sandwich. So A, B, and C, D are pieces of the sandwich for the bread, and C is whatever you want to put in the center. So we've got this right here, this two being congruent, and then those two being congruent, and this one, these are in between two sides. The best friends still apply here, okay, they still apply, and having all of that, you consider that these triangles are congruent. So it's congruent. So these are one type of mark on two triangles. Now that you've gone through to prove that this triangle, these two triangles are congruent, okay? If, this side, CI is congruent to FH, and C is the midpoint of both of those two. Okay, so I'll set down. Okay, everything is where it needs to be right now. So with this problem, sorry, I had some technical difficulties on my side. Okay, so with this problem, they're giving us a given. Like all the other problems, and you can see it's in your life. So here's one triangle. And here is okay. So those are what we're trying to do. Okay, so we put all the givens into one statement, which is not my favorite thing to do. So remember that I don't usually do this, but this was an already good thing. So this right there. Okay, is that dead end or is that giving something else? Okay, you're saying it's a dead end. So this whole thing. So this right here is going to this guy right there. That's what it's saying. So those two things are congruent. Okay, I can handle that. Okay, you can too. We're then going to look at this one. Use the midpoint of this and use the midpoint of the other one. So if these are midpoints, segments similar, then what is happening to the frequency ER? So the blue line is right here. That'll help. This line right here, get it? This line right there, if that goes the midpoint of it, sorry, okay. If the midpoint of that, then this guy is going to be congruent to that one. Okay. If that's the case, we also know that H is the midpoint. That means that these two are congruent. Okay? There we go. So if that's the case, this statement right here that's the relation. What is the reason? What would be the reason that that statement got congruent? Okay. Okay, so if that's the definition of midpoint, what is this one? So might be something you guys are not used to seeing. And it is one of your best friends. If you go back to the very first screen, looking at is this angle right here. FCE, this guy right there. That guy right there, and that one right there. What are those called? Vertical angles. Okay, vertical angles. So if we look at it, these are angles, and these are both our sides right here. The angle sandwiched in between the two sides is this. So we have side, angle. Okay, digest that. Okay, so I added this. You can either do it on the back or another piece of paper or somewhere in the corner of your notes. But CPCTC is only used when the proof statement is asking to prove parts of a triangle. Parts of a triangle. Those are angles and sides. If it's asking you to prove the triangle's congruent, you cannot use this. You cannot use this. So, cannot use to prove triangles congruent. Okay, very, very important. So a lot of students, I know you guys are my first ones this year. You guys aren't going to make this mistake. Okay, so just under your belt. Um, make sure you remember it, forget it, all that good stuff. All right, let's go to the next page. Okay, so here we go. Actually, let's go back a page. All right, guys, let's go back to this page. And I want to write something else down. Okay, so given parallel lines, then you can state angles congruent. Nothing else. Okay, nothing else. Most likely, it will it'll be alternate interior angles. All right, now let's do this problem. There's a reason I did that. So you're given that and TS, I'm so sorry, are parallel. Okay, you know how to do that. Parallel lines, and then a back. Okay, those are parallel. All right, so let's write that given down. So RQ is parallel to TS, and that's given. Doesn't like to give me, there it is, given. That was really odd. Okay, next one. Okay, but wait, what's the next one? We're gonna talk about that statement right there. If that statement is a dead end, then we're good. If it's not a dead end, then we need to discuss it. So if you are, if you say here, um, and PS are parallel, we are going to get some information from this that is going to be very, very helpful. Okay? So, okay. One thing I do want to write, I'm going to skip line 2 because there's a reason. I want to put down right here that RQ is congruent to ES, that's given. Okay, so that means that RQ, this guy right there, and this guy are congruent. Okay, that's great. Step back here. This angle right here and this angle right there is what we're trying to prove. Okay, trying to prove. Okay. Okay, so we have those two, QR and ST are congruent. Is there something in there that you see as your best friend? Your best friend? Is there a best friend up there? Anywhere? Anywhere? I don't know. So hopefully you guys can see that this right here is your best friend. So segment RT is congruent to RT, and the reason? Reflective, reflective property. Now, you have to be able to look at this and say, all right, I need to be able to see which angle now to pick for this guy right here. Okay? If we're using this side right there and this one right there, and we want to attach the center part, guess what? There's your alternate interior angles. This one right there and that one right there. So going back up to statement 2, we're going to put angle QRT is going to be congruent to angle SPR. Okay? Why? Why is that distance congruent? Alternate, alternate interior angles. Right, the last statement, almost there. You're out of 6 here, but that's okay. Before you conclude that you angle S, you have to prove that the triangles are congruent. So if that's the case, then we have side, we have an angle, and we have a side. So triangle QRP is congruent to triangle STR. What's the reasoning? Side, angle, side. Step 6, angle Q is congruent to angle S, CPCPC. Okay, so I understand that this is a long video. I'm really sorry. I was trying to do something with my iPad connected to my computer, which it works, but it took me a little while. So I apologize for the length of this. Do the best you can. The homework is on the next page. I also want you guys to look up other videos if you need to. And yes, I should be back this week, as long as my knee decides to hold up. All right? So, next page. Do your homework. Pause it, write it down. Please, please, please don't get loud with the sub. Just please do your work. I'd really, really appreciate it. Thanks, guys.